Okay, so we're continuing on with the same question, which was question number 8 from October, November 2017, paper 4.3. Okay, part C says find the equation of the line perpendicular to line A, which passes through the point 10, 9. Give your answer in the form y equals mx plus c. So now, the line A has equation, as we saw from before. The equation of line A is y equals, the equation of line A is y equals 5x minus 4. Okay, that's the equation of line A. So the equation of line A is y equals 5x minus 4. So the equation of line A is y equals 5x minus 4. Now, we want to find the equation of the line which is perpendicular to line A. If it's perpendicular to line A, it has to have a gradient which is the negative reciprocal of the gradient of line A. Okay, lines which are perpendicular, their gradients are negative reciprocal. So the gradient of line A is going to be 5. So the gradient of the line which is perpendicular to A is going to be not 5. Now 5 is the same as like 5 over 1, if you can think of it like that. So the negative reciprocal, first of all, is going to be opposite signs, it's going to be negative. And you're going to swap around the numerator and denominator, so it's going to be minus 1/5. So the gradient of the line that we need is minus 1/5. So to find the equation of a line, we need 2 bits of information. We need the gradient of the line, okay, which is given the symbol m, and we need any point on the line. Any point on the line. Now the gradient of the line we deduced from the fact that it's perpendicular to the line A, so its gradient has a gradient of minus 1/5, and the point on the line that we know it passes through is a point 10, 9. That's given to us in the question. So that's enough now for me to work out the equation of the line in the form y equals mx plus c. So we've got y equals mx plus c. So I'll replace everything that we know. The only thing that is unknown is c. So one of the points on the line is 10, 9 that we know of. So that means y is 9. The gradient of the line is minus 1/5, so you have minus 1/5 times the x coordinate of the line, which is 10. And you got plus c, that's a 10 there. Alright, so you have 9 is equal to now minus 1/5 times 10 is minus 2. And you got minus 2 plus c. You have to add 2 to both sides, so c is equal to 11. So now I know that m is equal to minus 1/5 and c is equal to 11, so I can fill in m and c in these places. So y is equal to minus 1 over 5x plus 11. And there we have the equation of the line, which is perpendicular to line A, and it passes through the point 10, 9. Now it says work out the coordinates of the point of intersection of line A and line B. Now, line A has the equation y equals 5x minus 4, as far as I remember. Is that right? Yes, and line B, it has equation 3x plus 2y equals 18. So line B has equation 3x plus 2y equals 18. Now if we want to find the coordinates of the point of intersection of these two lines, we have to find where they intersect. We have to find basically where they intersect is the point where they both have the same x value and the same y value. That's the point that they both share. That's one point where they both share. So when we want to work out the coordinates of the points of intersection, we've got to find the value of x and the value of y that satisfies both of these equations. Now that sounds familiar to you in algebra, hopefully. That's what happens when we solve a pair of simultaneous equations. Now this can be solved simultaneously in a couple of ways. The one that most people are used to is like the elimination method, where they would first line everything up in the same space. So what you'd probably do is you'd rearrange equation A. So it says everything, you'd say minus 5x plus y equals minus 4. So you basically make the x and y on the same side like this is done. So that's now equation A modified. And then you would say, okay, I'm going to use these two equations together. Okay, and that's equation 1 and equation 2. I'm going to solve these simultaneously. I have to make one of the coefficients the same. See, I can make the coefficients of y the same. I can multiply the whole of this equation by 2. So you get minus 10x plus 2y equals minus 8. You have to multiply all of it by 2. And then I'll write underneath it the equation that I'm going to use with it, which is 3x plus 2y equals 18. And then I can subtract these two equations from each other. I can subtract them because then the y's will disappear. So I can subtract them either way, this way or that way. If I do it, let's just do it the normal way that you're used to. So minus 10 minus 3 is minus 13. You've got minus 13x. And you've got minus 8 minus 18, which is minus 26. Okay, so you end up with minus 13x. Negative 13x equals negative 26. Divide both sides by 13. You got 2. X equals positive 2. That's the x value where they intersect. And we know that y is equal to 5 times x minus 4. So if I put the value of x into this equation, it'll be 5 times 2 minus 4, which is going to be 10 minus 4, which is 6. Okay, so that's the point where these two lines intersect. Okay, we solve these two equations simultaneously to find that point, the coordinates of the point where they intersect. Okay, so when lines intersect, they share the same x and y value at that point. Okay, that's how you can find out where they intersect. Then part E says work out the area enclosed by line A, line B, and the y-axis. Now this is where drawing a sketch is kind of like pretty much necessary. Otherwise you can't really picture what's going on. So that's what I'm going to do here. I'm going to draw a sketch. So I'll have my y-axis and my x-axis. Now, line A, the equation is y equals 5x minus 4. Alright, that means, let me just extend this a little bit so we can see what's happening. 5x minus 4, if I want to draw it, it will be a line that goes through minus 4. Okay, so what do we know about this equation? We know that it passes through minus 4, that's the y-intercept. Okay, this is line A. And we also know that line A passes through the point 0.80. We learned that in the earlier part of the question. Okay. We learned that over here. One second, sorry. If we go back up here, we worked out where the line passes through the x-axis, where line A passes the x-axis at 0.80. So I know it passes through somewhere over here, which is less than 1. Okay, that's 0.8 and 0. So this line, line A, will look something like this. We'll go through these 2 points. Something like that. Okay, that's line A. Line B, its equation is 3x plus 2y equals 18. So this is line A, which is y equals 5x minus 4. And then you've got y equals 3x plus 2y is equal to 18. So if you've got 3x plus 2y equals 18, how do we draw this line? Well, we need to know 2 points of the line. When x is 0, y is 9. When x is 0, y is equal to 9. So that means that's on the y-axis at the point 9. And when y is 0, x is going to be 18 divided by 3. When y is 0, you've got 3x equals 18. So x is 6. So it's going to pass through this axis at the point 6, 0. So we can now make a little sketch of this line. It's not accurate at all. Okay, when, yeah. There we are. So that's the line, 3x plus 2y is equal to 18. Now, we also know that they intersect, okay, at a particular point, which is a point over here. Okay, now the coordinates of this point, well, this value is the x value, which is 2, and this is the y value, which is 6. Okay, it's not drawn accurately, it's just a sketch, so it doesn't look like that's 6, but it is. Okay, so that's the point 2, 6. We just worked that out in the last part of the question. Now they're telling us to work out the area enclosed by the line A, the line B, and the y-axis. So they're asking us to find the area that is enclosed in this region over here. Okay, the area enclosed in the region over here. Let me just make it a different color. So they're asking us to find the area in this region over here. Make it so that area is the area of a triangle. Now if you think about the area of this triangle, you can think of this as the base. Now this is between 9 minus 4. So the length of this base, we got 9 units that way and 4 units that way, that's 13. 9 minus 4 now, so the distance between them. And you can think of the vertical height as this here, 2, 6. So this here is the vertical height. Okay, this is 2 units. So you can think of this triangle as the area being a half times the base. Now the base we've taken as 13 times the height, and the height we've taken as 2 units. 2's cancel out, you're left with 13. So it's 13 square units. Okay, and there's our answer. So that's how we deal with part D and E of this question. I hope that was clear, and thank you for paying attention and watching. So that's A, B, C, D, and E. We've done parts C, D, and E in this video. Okay, the one previous to this we did A and B.